This is Algebra 2, Chapter 5 review. We're looking at exercise 18, where we have this quartic polynomial, fourth degree polynomial, and we need to graph it. Now, the first thing we need to do, in order to know what we're doing about graphing it, is to factor it. So let me rewrite it over here so we have room to work with. And then we need to look at factoring it. Always begin factoring by looking for common factors, and there's an x squared that's in common, and since the leading term, the leading coefficient is negative, we'll go ahead and factor out negative x squared. That leaves us with x squared minus 4. And that factors pretty quickly into x plus 2 and x minus 2. Now, this kind of factoring is probably pretty straightforward for you. If for some reason it's not, then you'll want to go ahead and use the quadratic formula. Once the polynomial is factored, we're ready to write zeros. We have a 0 at x equals 0, and that comes from the x squared sitting in front. We have a 0 at x equals negative 2. That comes from the x plus 2. And we have a 0 at x equals 2. That comes from the factor of x minus 2. With that information about the zeros, we are ready to go ahead and make a couple dots on the graph. Negative 2, 0, and 2. Boom. Okay, that's not actually 2. There we go, 2. From there, we need additional points. I've seen a lot of people in class making t-charts, xy t-charts. Certainly, there's no problem whatsoever with that. At this point, oftentimes we don't do that. We just show function values. It doesn't really matter. Maybe you start at negative 3. It's a little bit to the left of the first 0. But the answer ends up being negative 45. So we won't be graphing that. If for some reason you forget and you substitute in negative 2, you'll get 0 and you'll say, oh yeah, I already knew that. Then substituting in negative 1 gives you 3. So we can go ahead and throw down that point, negative 1, 3. Substituting in 0, if you do, it gives 0 and you say, oh yeah, I knew that, probably shouldn't have even bothered. But no harm. Substitute in 1, you'll get 3 again. Substituting in 1 gives you 3. So you make that dot. Again, if you substitute in 2, you get 0, and you perhaps grumble to yourself, you knew that already. If you substitute in 3, you end up with negative 45, and some sort of response of there's no way that's happening. Now, before we make the graph, we need to talk about end behavior. Because it's a quartic, fourth degree, and it has a negative leading coefficient, that means, this is important, that the end behavior, both arrows go down. So because of those two things, both arrows go down, like an upside down parabola would. Even degree, in this case it's 4, but even degree with a negative leading coefficient means it's an upside down even degree thing. The arrows both go down. So we know to a certain degree the arrows go down, the arrows go down like this, and like this, and we're left to connect the dots. Now, I put the arrows near negative 2 on the x because if you remember, the negative 3 and the 3 values were so small that we knew it didn't pass there. Probably wouldn't look for that on the test though. The function goes through the 0 at negative 2, goes up and comes down. We don't worry too much about exactly where it goes up and comes down. In fact, in this class we don't worry at all. Now here's the tricky thing right here. At 0 it bounces back up, and the reason why it bounces back up is because of the fact that x squared is a double factor, so x equals 0 is a double 0. So because x equals 0 is a double 0, it acts like a parabola right around x equals 0. Now, that green circle I just made is not actually part of your graph, but the squared on the factor makes it act like a parabola at the 0 that comes from that factor. I already did it. The rest of the curve goes up, comes back down, goes straight through at x equals 2. It's a single factor. And there we have our graph. At this point, I'm going to erase that green circle on the graph. There we actually have our graph. Thank you for watching.